Okay, college algebra, we've talked about some of these quadratic inequalities when you have the typical situation when you can factor. But we need to know what to do when we can't factor. So we have to use another technique. So let's look at x squared plus 3x plus 3 is less than 0. That can't be factored because the only factors are 3 and 1, and those would add to 4. So we have to use an alternate method for finding the solution here for x squared plus 3x plus 3 equals 0. So we're going to use the quadratic formula, which is negative b, so negative 3, plus or minus the square root of 3 squared minus 4 times 1 times 3 all over 2a, so 2 times 1. So negative 3 plus or minus the square root of it looks like 9 minus 12 over 2, which is negative 3 plus or minus the square root of negative 3 all over 2. Now, when you have a positive number under the square root here, that means you'll have two real roots. However, since we have a negative under the square root, that means we have two imaginary roots. Now, on a graph, that means that we can't see the roots. So it means it's either the quadratic's either fully above or fully below the axis. So that means our points, like we had over here with negative 4 and 3 halves, we don't have any of those because there are no roots we can see. That means the whole graph is either above or below the axis, which means I only have to test a single point. And of course, the easiest point to plug into the original is going to be 0. Whatever 0 does, everything else does. And it's easy to look at the original and plug in 0 because the only thing that will survive plugging in 0 is the constant. So we get a positive number because it would be 0 plus 0 plus 3. Is that less than 0? No. That means 0 doesn't work, and if 0 doesn't work, nothing works, so there is no solution. So for the problems where you have imaginary roots, it'll either be no solution or all the numbers will be solutions, and you only have to check 0 in order to figure out which of those it is. Now we can have some word problems that are similar to other problems we've had before, but now are asking you for inequalities instead of equal signs. A projectile is fired straight up from ground level. After t seconds, the projectile's height above the ground is s feet, given by the equation s equals negative 16t squared plus 128t. During what time interval is the projectile at least 192 feet above the ground? So s's position, so if it's above 192, that means this equation has to be greater than or equal to 192. Okay, so now let's move everything to one side by subtracting 192. When we divide by negative 16, we need to make sure that since we are dividing by a negative number, that is going to change the direction of our inequality. So we get t squared minus 8t plus 12 is less than or equal to 0. I can now factor this. T minus 6, t minus 2. So we're going to treat this like it's equal to 0, of course, to find our critical points, just like we would on other problems. So t equals 6 and t equals 2. So these are my two values, 2 and 6. I have to test something between them. And on the outside, so we'll do 0, 4, and 8. So at 0 seconds, this is positive when we plug it in because 0 minus 0 plus 12 is 12. When we plug in 4, 4 minus 6 is negative 2. 4 minus 2 is positive 2, so they multiply to a negative. When I plug in 8, it's positive times positive, which is positive. Now, I'm looking for things that were less than 0 in this equation, so these two are out. This one makes sense, so it's between 2 and 6. Now, since this is a word problem, we should write a word answer. The projectile is at least 192 feet in the air. Between 2 and 6 seconds. Generally speaking, on the projectile problems, the middle one will be the right answer. The reason for that is the projectile has to go up and then down. We don't really have the option, unless it's asking you at what time periods is it less than a certain amount, then it will be the outsides. But that's the only way it can work with projectiles. And lastly, we need to talk about rational inequalities. So like quadratics, rationals will have critical values and they'll require you to test points. Now, unlike quadratics, we won't necessarily factor, but to find the rationals, you have to set the numerator equal to 0 and the denominator equal to 0, and those are our critical values. So the first thing you have to do is get the whole thing equal to 0, and you need it to be in one fraction. So combine using common denominators, and then set numerator and denominator equal to 0. Then you test your values. Step 2 gives you your critical values. Okay, so this one's already equal to 0, already in one fraction. So let's set the numerator and denominator equal to 0. So x equals 5, or x equals -4. Make our test chart. Find points. 0, we'll do 6, and -5. Okay, so when I plug in -5, we get -5 minus 5 over -5 plus 4. That's a negative over a negative, which is a positive. When I plug in 0, I get 0 minus 5 over 0 plus 4. It's a negative over a positive, which is negative. When I plug in 6, 6 minus 5 over 6 plus 4. Positive over positive is positive. Now what are we looking for? We're looking for ones that are less than or equal to 0. So that's that middle term. Now normally, in the quadratics, because this was a less than or equal to sign, we would use braces. However, that is not the same case here. In the numerator, we can plug 5 in originally, so 5 is fine. However, we can't plug in -4 because then we are dividing by 0 here. Because -4 plus 4 is 0. So any of our boundaries that come from the denominator, they don't get a brace, they get a parentheses. But the numerator can still have the brace. So just keep that in mind. Now what happens if the fraction doesn't start equal to 0 in one fraction? Then you've got to move things over. So now it's all on one side, but it needs to be in one fraction. So I need to change this 1 into a common denominator of x minus 3. So that's x minus 3 over x minus 3. And then I need to combine my numerators. 5 minus x minus 3 becomes really, 5 minus -3 is really 8 minus x. X minus 3 is greater than or equal to 0. And then I'm in business. Once I'm here, 8 minus x equals 0, x minus 3 equals 0. So either x equals 8 or x equals 3, and I make my chart. Now because x minus 3 came from the denominator, that one will never get a brace. So I plug in points, we'll go 0, 5, and 10. Plugging into my fraction, 8 minus 0 is 8. So we have 8 over, so positive over negative, which is negative. Plugging in 5, we have positive over positive, which is positive. Plugging in 10, we get negative over positive, which is negative. We're looking for the area that is less or greater than or equal to 0. So in this case, we're looking here. We're looking for the positive number. So this one's fine, and we have 3 to 8. Now, you can have outer regions instead. That can occur, but there are some of those on the review, and we can see what that happens, what that looks like in class. But this is the end of 1.7.